Next, what we're going to do is start thinking about how we can manipulate lists. And this is going to be good because it's going to give us a little bit more practice with lists and with the underlying programming constructs, conditionals, while, and for loops. Okay, so let's go ahead and get started by way of an example. I give you a list. I know this is a list again because I have the square brackets, I have comma delimited. There are 6 elements indexed from 0 to 5. And I ask you to write some Python code that reverses the list. So I want L to read instead of A, B, C, D, E, F. I would like it to read F, E, D, C, B, A. So that should be F. That should be E, D, C, B, A. Okay. So because we're good coders now, we should think about the algorithm before we start writing code. So let's think through the algorithm a little bit. So what do I want to do? There's a couple ways to do this. Here's the way I'm going to think about it. I'm going to take these 2 elements and I'm going to swap them. And I know that since I'm reversing the list, this, which is now the last element, should be the first element, and this, which is the first element, should be the last element. So I'm going to just swap them. And then, of course, I have to keep going in. So then I'm going to take these 2 elements and swap them. And I know that it's these 2 elements because this is the second to last, and this is the second. So when I reverse the list, those 2 must switch position. And then one more time I switch those, and then I'm done, right? And then I will have F, E, D, B, C, A, B running from right to left, from left to right rather. All right, so here's a little bit of pseudocode. For every item in the list, swap the item with its corresponding last item. Okay, that's what I just said. All right, let's see if that works. For every item in the list, okay, I'm going to swap these 2. I get F and A switched. B and E switched. C and D switched. For every item in the list, oh, I'm going to keep going because I said for every item in the list. So now I'm going to swap again, and swap again, and it's a no-op. I've gone from a full reversal when I was right here, and then I re-reversed it. So that's not quite right. I'm not swapping every item in the list. I'm only swapping the first half of the items in the list. All right, so let's fix that. For the first half of items in the list, swap. Okay, swap, 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 good. Now this list happens to have an even number of elements. What if it was an odd number of elements? Okay, so what does half mean? Okay, well, let's fix that. For the first half, round down of the items in the list. So let's see what I mean by that. So this has an odd number. 5 divided by 2 is not an even number. Let's see what happens, though. I'm going to flip these 2. I'm going to flip these 2, and what happens to C when there's an odd number? Nothing. There's nowhere to go. It stays put. And so all I have to work on is these 2 elements, and that item can stay in the middle, so I can round down. So 5 divided by 2 is 2.5. I'm going to round down to 2, and so I'm only going to swap the first 2 with the last 2 elements. All right, that seems to be about right now. And look at how we needed 2 iterations to get that right. So this again emphasizes why you should think about these things carefully before you start writing code. All right, now let's see what the code looks like. Well, before we do that, the basic operation is swapping. All right, so let's make sure we know how to swap 2 elements. And then once I can swap 2 elements, it's really just a matter of putting the looping construct around it to get it to sort of do it everywhere. So let's think about that swap. How do I swap these 2 elements? Well, I've got the pieces. I know that I can access this element as L sub 0. And I know I can access that element as L sub 4. 0, 1, 2, 3, 4. And so what I want to say is that L sub 0 gets L sub 4, and L sub 4 gets L sub 0, right? So let's see what happens if I write those 2 lines of code right here. So again, on the right-hand side of the operator is accessing the 4th element and the 0th element. And on the left-hand side is assigning that. All right. So imagine this is my list, and let's evaluate that first line of code right there. So what does the list look like after I do that first line of code? L sub 0 is equal to L sub 4. So I shove an E right there, and my list is now E, B, C, D, E. Okay? And I've just done it without the commas and the quotes just to make it a little bit more compact. Next line of code, what do? L sub 4 is equal to L sub 0. What happened to A? I've clobbered it. It's gone. So now when I do this line of code, I've lost A. So once I do that one line of code, A is gone bye-bye. And now I have a problem, right? I've lost that element. So I sort of want to do these sort of simultaneously, but I can't, obviously. I can only do one line of code at a time. And so what do we want to do? Well, we want to hold on to that A, overwrite it with E, and then shove that A back into that position. So what is that going to look like? Well, let's hold on to A. So temp is equal to L sub 0. It's a temporary variable. Now, when I write L sub 0 is equal to L sub 4, I've lost the A there, the E is still there, but I'm holding on to A in this temporary variable. And now I simply say L sub 4 equals not L sub 0, but the temporary variable, because L sub 0 has been overwritten. So look at those 3 lines of code right there. That's a swap. I hold on to a temporary variable of what I'm about to annihilate. I annihilate it. And then I take that temporary variable and I shove it back where I want. And notice, by the way I've written this code now is I started with a little bit of a sketch of an algorithm. I didn't try to write the whole code. I just thought, I got to swap these things. Do I know exactly how to do that? No. So let's just work through this. You could have just written these 3 lines of code to just make sure you can swap one element. Right? So there's a really nice example of incremental code building. One step at a time. Solve one problem, debug it, test it, make sure it works, and then move on to the bigger problem. Because now, once I can solve this, I can solve this, and I can solve this by simply looping over the constructs. Okay, so now we've got the basics. We have the code, the algorithm, and we have the basic structure for swapping. And now let's put all the pieces together. Let's just make sure this, by the way, works for the other elements. So 0 and 4. So to swap the next element, I'm going to swap 1 and 3. So temp is going to be equal to L sub 1. That's B. L sub 1 is going to be equal to L sub 3. So I've got 2 D's in here. And then eventually I put the B in it. And of course, for the next element, I don't care because that's the midway point. All right, good. Let's put it all together now. I define a list up here. I is going to be 0. I'm going to do this with a while loop, and I'm going to show you later on that you can also do it with a for loop. So 0, 1, 2, 3, and that's sort of where I want to stop, right there, right? Because I want to swap the 1 and the 15, the 3 and the 13, the 5 and the 11, and the 7 and the 9, and then I want to stop. So this has an even number of elements, so I want to go from 0, 1, 2, 3. All right, so let's check the while loop. I starts off at 0, that's the first position. I is less than or equal to the length of the list, that's 8, divided by 2 is 4, and I have a less than there. So I will take on the value 0, 1, 2, 3. Look at how careful you have to be when you write that one line of code. You have to think through these little off by 1 errors really, really carefully. I can't emphasize how easy it is to get these wrong. So I now will take on the value 0, and it will stop at 4, actually at 3. And then, of course, on each iteration, I will be I plus 1. I'll fill this in a minute. Okay, good. So this looping construct is going to swap 1 and 15, 3 and 13, 5 and 11, and then 7 and 9, and stop. Okay. What is this line of code? So I know that this is the position I want to swap with something over there. J is going to be that index, and I'm going to come back to that little line of code in a second. And then hopefully what's going to happen is I'm going to increment I, and then J will come in. So you can think about this as I being a pointer to here and J being a pointer to here. And then I increment I by 1, I decrement J by 1. I increment I by 1, I decrement J by 1, and so on and so forth. All right, so we'll see how that line of code works in a second. But let me look at this line of code right here because this looks familiar. By the way, notice that I have comments in here. So what do I want to do? I want to swap what's in position I with what's in position J. Temp equals the ith element of the list. The ith element gets the jth element. The jth element gets the temp element, the variable temp. So there's my swap. So as soon as I can convince myself that this is right, we're home. Yeah, because everything else is now in place. So let's see what's going on with that one line of code. All right, first line of code. First line of code, define a list. Second line of code, increment, set I to be equal to 0. This condition, of course, holds. And I come in here and I set J to be the length of the list. What is the length of the list? The number of elements, that's 8. Minus 1 minus I. Let's see what's going on here. Length of the list is, and remember, by the way, I want J to be what? The index into that number. What is that? 7, 6, 5, 4. Okay, good. So it's the length of the list, which is 8, minus 1 minus I, which is 0, and that, of course, gives me 7. So think about it like this. Get rid of the minus I. If it's just length of the list minus 1, that's what that position is, always. And since I is 0, I'm going to get that position. And then notice what happened here. When I increment I I'm going to always be decrementing 7 by 1, and then 7 by 1 and 7 by 1. So you can see that, and I'm going to do it in a second. All right, so on the first iteration, I is 0, j is 7. And then what do I do in the swapping code? I swap those elements. Good, 15 goes up front, 1 goes to the back. I increment I by 1. I come back to the conditional, still true. Now, I is 1, so j is going to be the length of the list, minus 1, that hasn't changed, minus 1. So I've gone from 7 to 6. As promised, I've just decremented that value of 7 by 1. Good. Swap what's in the 1 position with what's in the 6 position. Excellent. Let's do it again. I is 2, j is 5. Swap those 2 positions. Do it again. I is 3, j is 4. Swap those 2 positions. And then what happens? I is 3, we evaluate, we swap. Increment I by 1. What is the value of I now? It's equal to 4. Is 4 less than or equal to 8 divided by 2, which is 4? No. And then we're done. We've swapped the list. Very nice. Okay, that's the last iteration right there. All right, let's do that whole thing with the for loop now. Okay, and yeah, this is just as an exercise. There's nothing wrong with the while loop construct here. So same thing, define the list to be 8 elements, 1 through 1, 3, 5, 7, 9, 11, 13. Oh, sorry, I've got 8 elements. Good. Now, for I in, I don't know, something, and then j is going to be something. So let's think about what we want to do. It's the same game, right? I need an index into that position. I need an index into this position, and then I'm going to swap. So notice the swap code's exactly the same. I is going to be the first position. J is going to be the corresponding last position, and then I swap the code. So all I've got to do is get I and j right, and then I'm home. All right, so what's I going to be? Well, we know I want the value of I to be 0, 1, 2, 3, and then I'm done. So it is the range of 0 to the length of the list divided by 2. Let's make sure we're not off by 1. What's the length of the list? 8. What's 8 divided by 2? 4. Remember the way range works. It's going to give me 0, 1, 2, 3, but not 4. That last element doesn't give me 0, 1, 2, 3. That's exactly what I want. Good. So I now is going to give me 0, 1, 2, 3. What do I want j to be? I want it to be the corresponding value at the end of the list. Well, I already know how to do that. It's the length of the list minus 1 minus I, because I is taking on, again, the first 4 integers starting at 0. So j is just the length of the list minus 1 minus I, and then we're home. So is this better or worse? I don't know, it's a little cleaner. It's fewer lines of code. I didn't have to initialize a variable. I didn't have to do a conditional check. I didn't have to increment I down here. And so it's a little cleaner. If I had to choose, I'd probably do it with the for loop. I actually like this. Now, here's a question for you to ask yourself. Could I have done this with the construct that taps into the value? So what would have happened if I said for I in L? Yeah. So that means I would take on the value 1, 3, 5, 7, 9, 11, 13, 15. Could I have done the swapping? No. Why? Because I really need to know the index. Why do I need to know the index? Because I have to swap them. So in this case, I'm not asking are these numbers even or odd. I actually want to manipulate them. And to manipulate them, I need the index. So here's an example where you really have to do it this way. You need the index, not the value. The value is sort of irrelevant to you. What's stored here, you couldn't care less. You're just swapping them. So here you really do need to get the index. And you could have done that with this type of for loop or with a while construct. Okay, here's a drill for you to do some practice. Write some code that prints has 22 if the list contains a 2 next to a 2 anywhere in the list and prints no 22 otherwise. Okay, so what do I mean by that? I give you a list of obviously a bunch of numbers. And let's say the list is 1, 2, 3, 4, 5, then you should print no 22, no 22. But if the list says 1, 2, 3, 2, 2, 5, 7, 9, you should print has 22, and you should only do that once, by the way. So here's a little trick. Imagine now I have the list 2, 2, 4, 7, 2, 2. Now that list clearly has a 2 next to a 2, but I only want you to print has 2, 2 once. If you print more than once, it's fine, but try to do it once. And here's a little hint. Use the break command in the same way that we used in the while loop. So you can shove a break inside of a for loop, and like a while loop, it will kick you out when something is true. Yeah, there's a little hint. But if you don't get it, don't worry about it. Here's the other hint. This is a little bit like that prime example. So what do I mean by that? You're looking for something. And if you don't find it, then you have to tell me something. So in your looping construct, as you're looking for the 2, 2, you've got to keep track of whether you found it or not, because when you get out of that loop, you have to tell me something. Okay, so here's my advice. Start simple. Just try to print has 2, 2, regardless if it's once or twice or I don't care. And don't worry about the no 2, 2. Just write a little code that just does this. Now, once you get that working, figure out how to only do that once if there are 2 sets of 2, 2s. And then once you get that working, figure out how to return no 2, 2 at the very end. Okay? So, pause, take a breath, write some code, sketch it out on a piece of paper, and then build it up incrementally the way I just described. And when we come back, I'll show you my solution. All right, I hope you got a solution, but if not, it's okay. We'll keep practicing, it'll get better. So here's my solution, and let me just say, this is not the only way to do it. As our code gets more complex and there's more lines of code, there's going to be lots of ways to do it. So just because yours doesn't look like this, it's fine. There are many, many ways to do this that are equally good. All right, so let's see. I'm going to define a list, 1, 2, 3, 4, 5, 6. This one happens not to have 2, 2, but of course you want to test this with lots of different lists. And I'm going to define a variable called flag, and we'll come back to that in a little bit. Now, I did this with a for loop. You could have done this with a while loop. I think you should practice with both so you don't end up sort of favoring one over the other, because sometimes they're both equally valuable. And what am I going to increment over? Let's see. I obviously want to check this value against this value, so 0 versus 1, and 1 versus 2 to see if the neighboring ones are 2. And eventually I'm going to get to this element right here, the second to last element. I want to check if that's a 2. But once I'm here, there's nobody to my right. And so I don't want to check that element. So I is going to take on the value 0 to the length of the list minus 1, which means the last value of I is going to be that index right there. I'll compare that number to that number, and then I'll stop. Otherwise, I run the risk of going over and indexing an element of the list that doesn't exist. So I is going to be 0, 1, 2, 3, 4, and then I'm going to stop. Okay. Now, I'm going to ask, if the ith position is equal to 2 and the I plus 1th position is equal to 2, well then I found a 2, 2. Yeah. So let's see. If L sub I is equal to 2 and L sub I plus 1 is equal to 2, then I found a 22, and I'll finish this code in a second. Notice, by the way, that I plus 1 right there is why I have to stop 1 early. Because if that I is the last element in the list, and I try to index outside the list, what happens? I get an error. Okay, so that little minus 1 right there is adjusting for that little plus 1 right there. Okay. So if I find a 2 in the ith position and I find a 2 in the I plus 1 position, I found a 2, 2. So print has 2, 2. And now look what I'm going to do. I'm going to set a flag, just a variable, to 1. You can think about, I could have done this, by the way, false and true as well. And I'm going to break. So this break kicks me out of the for loop. Why am I doing this? Well, as I said earlier on, I only want you to print this once. So if there was multiple sets of 2, 2s, then I would have kept going and going, and I would print has 2, 2, has 2, 2, has 2, 2, has 2, 2. By the way, very similar to the is prime. So if I found a number that was an even divisor and I said not prime, not prime, not prime, not prime, it's not wrong. It's just, okay, I get the point. It's not prime. I get the point. It has a 2, 2. Now, if I'd asked you to count all of them, then you don't want to break. But if I just tell you, if I ask you to tell me if there's there, you want out. You're done with the for loop. You've gotten your answer. Okay, so if you did it incrementally the way I said, you didn't need the flag, and you didn't need the break, and you didn't need this little bit of code that I'm going to review in a second. You would have just kept printing has 2, 2, and if it wasn't there, it would have just done nothing. And then this flag plus this break, the break is what says only do it once, and then the use of the flag plus this bit of code here is what tells me that there is no 2, 2. So let's do that part now. Now, I run through this for loop over and over again. Before the for loop starts, flag is set to 0. When will flag be set to 1? Here, and only here, which means I found a 2, 2. So if I get at the end of this for loop and flag is still 0, what do I know? This conditional was never evaluated, which means I never found 2, 2, which means I know there's no 2, 2. So if flag is equal to 0, there's no 2, 2. It was never found. So this little state variable is keeping track of whether this little bit of code was evaluated. Now you may remember in is prime, we did something different. We did it by looking at the value of I at the very end. I like this solution better. I think it's a little bit more sort of clear. I think the code is clear. You could put a comment here saying what it's doing. And although it's a little bit more code, I have to initialize a variable. I have to reassign the variable. I think it's worth doing it because I think the code is a little bit cleaner this way. So these are called state variables. They tell you if this little bit of code was evaluated because you need to know that out here. Notice, by the way, this is a nice little bug that I'm sure some of you got. If I had written else, print no 2, 2, it wouldn't have worked. Why? Because you would have checked the first two elements of the list. They would have not been a 2, 2, and you would have said no 2, 2. So you only can say there's a no 2, 2 when this entire for loop has evaluated in its entirety. This is only checking one element. You've got to do that over and over and over and over and over again, and then when you're done, then you're home. Okay, good. So hopefully now you're getting more comfortable with lists. Hopefully now you're getting comfortable with for loops and the interplay between the two of them. All right, that's it for now, and we're going to pick it up in a little bit. See you soon.